Alright, so in this video I'm going to focus on page 35 where you're looking for the distance between 2 points. And I know in your notes there's a formula, but remember how we did it in class with the Pythagorean theorem? That's what we're going to do here, and that's what I'm going to do here on the video. So the first thing is identify the endpoint. So here you have this endpoint -2, 1, and this one 4, -5. I'm going to give the points a name, so I'll call this one A and this one B. Okay. Next thing is I'm going to draw a right triangle. Now it could go above the segment or below. For this one, I'll just draw it below. So let's go straight down. We want to form a right triangle. Okay, it has to be a right triangle for this to work. There's your right angle right there. So we count. Okay, from here to here, how many spaces is that? How many squares is it? So it's 2 right here, and then 5 more right here, right? So 2 and 5 total is 7. Going this way, you have 1 right here on the left side, and then you have 4 more, so 4 and 1 is 5. Okay? To find AB, the distance AB, you take the square root and then you square the sides, so 7 squared, and then add them together. Okay? And then take the square root of the sum. So this is going to be 7 times 7. Remember, it's not 7 times 2. Okay, so 7 squared does not equal 7 times 2. Okay, be careful with that. 7 times 7 is 49. 5 times 5 is 25. So we add the numbers together and we get the square root of 74 when you add those together. So that's the distance from A to B, from here to here. It's the square root of 74. Okay, number 3, we're going to draw the triangle. Okay, this time I'll draw it above. So you know it doesn't matter, right? It doesn't matter if you draw it above or below. There's right angle in the corner. This time I'll call them D and F. Okay, and so we label the sides. So I have this distance right here is just 1 square, and this distance right here, it's 4 and then 2 more. So that's a total of 6. So 6 right here and 1 right here. So DF equals the square root of 6 squared plus 1 squared. So that's square root of 36 plus 1, which is the square root of 37. So DF is the square root of 37. Alright, so number 2, we draw our right triangle. This time I'm drawing it below the segment. Let me call the segment PQ. We're looking for the distance PQ. So remember, we count this length by counting the squares. So 1, 2, 3, 4, 5. And then you count from top to bottom. The other side of the right triangle is called the leg because it's a right triangle. So we figure out the length of this one. So it's 5 right here, and then 4 more. So 5 and 4, the total distance here is going to be 9. Okay, just forgot to draw the right angle right there. So PQ equals the square root of 5 squared plus 9 squared. So that's 5 times 5, 25. 9 times 9, 81. We add them together, it's going to be 106. Later on we're going to simplify radicals, but for now we'll just leave it like this. PQ, because some of them may simplify, some don't, but some may simplify further, so we'll just leave it here for now. Okay, for number 4, I'm going to draw the triangle going up. There's a right angle right there. We'll call the points, the end points, CD. Excuse me. We find the distance from here to here. So it's 1 square right there, and then it's 4 squares more, right? So 4 and 1 is 5. So this is 5. And then we find this one right here. It's 1 square right there, and then 2 more right here. So the total is 3. So CD is the square root, don't forget the square root, of 3 squared plus 5 squared. So that's 3 times 3, 5 times 5. And so 9 and 5 is 34. So CD is the square root of 34. Okay, so for number 5, I'll go below the line. So we'll draw this triangle right here, right triangle. There's my right angle. We'll call the points S and T, the endpoints. So I know that the distance, the short leg, is 1 unit long. And then I count 4 squares across and then 5 more, so that's 9. 9 across. So ST is the square root of 1 squared plus 9 squared. So that's 1 plus 81. And so that's the square root of 82. That's ST. For number 7, I'll draw it going this way. There's the right angle. We'll call it MN. MN right there. So the leg going down is 3 units long. The one going across is 2 units long. So MN is the square root of 2 squared plus 3 squared. So that's going to be 4 plus 9. And then you square root that. Square root of 13. So that's the length of MN. Alright, so for number 6, I'll draw it going across and up. There's a right angle right there. So I know that the distance across is 3 squares and the distance down is 1 squared. We'll call the segment LM. So LM is the square root of 3 squared plus 1 squared. So 9 plus 1 square root of that will give you square root of 10. Now, you know that addition is commutative, right? I could have written 1 squared plus 3 squared right here. It doesn't have to be in this order. I would still end up with the same answer. Number 8 we did in class, but I'll just do it here quickly. Going down this way. So this is 1. And it's 1 above, 4 down, so that's 5. And we'll call it P and Q again. So PQ is square root of 1 squared plus 5 squared. So that's going to be 1 plus 25, square root of 26, and that's your PQ. Now, when they give you the points not on a graph, you can either sketch your own graph and count or draw your triangle just like we did the other examples 1 through 8, or you can just you know that you're looking for the distance, right? So you can do it this way. The distance from -3 to 2, because those are my x's. So from -3 to 2 the distance is 5. So from -3 to 2 the distance is 5. From 4 to 1 this distance is 3. So then PQ is the square root of 5 squared plus 3 squared. So 25 plus 9 square root of 34. So I would have gotten the same answer by drawing it on a graph, on an XY graph, but I just wanted to show you this different way when it's a little bit faster and you don't have to draw it. Unless if you feel it's going to help you, by all means, graph it and draw the triangle and all that. Okay? Alright, so I left the worksheet on midpoint in the classroom, so I'm just making these up. So these don't match any of the ones in your worksheet, okay? But just follow the examples. And then just follow this, and then on the test tomorrow, this is what you would do, and on your worksheet too. So make sure you finish it before you get to class. So remember the midpoint, we're looking for the point halfway between A and B. This is where A is, and this is where B is. So we're looking for the point that's halfway between the two. So we take the average of the x's and the average of the y's. We add the x's together. So it's going to be the midpoint. We're going to add the x's together and then divide by 2. So this one and this one. And then for the y coordinate, we add the y's together and then divide by 2. So 2 plus 6 divided by 2. So, and for the x coordinate, 3 minus 1 is 2. And then for the y coordinate, 2 plus 6 is 8. And then 2 divided by 2 is 1. 8 divided by 2 is 4. And there's your midpoint. Okay? Same thing on this side. We're looking for the midpoint, M. We take the x coordinates and add them together. So 2 plus 5 and then divide by 2. And then we take the y coordinates, which would be the 0 and the negative 4, add them together, divide by 2. So this is going to give me 7 divided by 2, and this is going to give me 0 minus 4 is negative 4 divided by 2. The first, the x coordinate, you could leave it like that, or you could write it as 3.5 if you like, and then the y coordinate is negative 2. So this is the midpoint. Alright, so another type of problem is where under midpoint is where they give you the midpoint and one of the endpoints, and your job is to find the other endpoint. So I drew this scenario right here. So point A would be somewhere around here, negative 5, 6. The midpoint would be about here, 1, 3. And we're looking for the coordinates of this point right here that would make this segment equal to this segment. Okay? Because the midpoint is right there. That's what we're looking for. We're looking for this x and this y. And so just like in class, I'm going to set it up for you the same way. The midpoint, I'm gonna connect the x with the x. So it's going to be, the midpoint is 1 for the x, and I got it by negative 5 plus some number x, we don't know what it is, divided by 2. For the y, it's the 6 with the 3. The 3 is a midpoint coordinate, and we got that midpoint coordinate by adding 6 to some other number y and dividing by 2. Okay? So to solve for x, we're going to multiply both sides by 2. So on the right side, the 2's are gone. 2 divided by 2 is 1. On the left side, I have 2 equals negative 5 plus x. I need x by itself, so I'm going to add 5, add 5. So 7 equals x. Okay, now I move on to the y. Similar thing, I'm going to multiply both sides by 2. 2 and 2 over 2 is gone. 2 times 3 is 6.